Unit 3 Chemistry, Chapter 3, Part 4. Okay, so now we know about gases, now we can think about burning them. A quick refresher on thermochemical equations. Remember, that tells you the enthalpy change over the course of the chemical reaction. And if the delta H value that you get is negative, it's an exothermic reaction. If it's positive, it's endothermic. Exothermic, we are giving out heat. Endothermic, we are taking in heat. Okay? So if we're given the delta H for the reaction, we can calculate how much energy is given out by reacting a specific amount of it. Okay? In your data book, there are molar enthalpies of combustion for 1 mole of the substance. You'll notice they're all negative. All combustion reactions are exothermic. And these are just some common things that we can burn as fuels. Okay? For almost all of them, our products are going to be carbon dioxide and water, because combustion is always a reaction with oxygen. The exceptions: hydrogen, react with oxygen, we just make water. If you had just carbon, react it with oxygen, you just make carbon dioxide. But all the rest of them, carbon dioxide and water, because they have both carbon and hydrogen in them. These delta H values are used so we can calculate the amount of energy released by a certain mass. Or if we know the amount of energy, we can calculate what mass was released. Okay? For each of these, this is per 1 mole of the substance. Okay? Be careful about that. Sometimes when you balance your equation, you're going to end up putting a 2 in front of this to double the coefficient so you get it all balanced. That's fine, but be aware that you would then have to double this when you write your thermochemical equation, and that when you use the value in your equation, you would then half it again. We'll look at that again in a bit. So, to use molar enthalpies of combustion, they're all reactions with oxygen. Okay? We're going to use E equals delta Hn. Okay? Energy is the change in enthalpy, which is in your data book, times the amount in mole. So, points to remember. You're given the value in a thermochemical equation, it takes notes of the coefficient in the equation. Okay? So if in your equation it says that you are burning 2 moles of butane, then the delta H value at the end of that thermochemical equation will be for 2 moles of butane. Before you use E equals delta Hn, you have to divide that delta H value by the coefficient in your equation. If you're using a value in your data book, don't go mucking around with it at all. If you're using the value in your data book, that is already per 1 mole, so you can put it straight into here. Okay? And remember that if at any point you are reversing a reaction, you've got to reverse the sign.